All right, good morning. I'm planning on doing a random Leetcode contest. So here we go. Just do, see, a random virtual contest. Okay, here we go. Biweekly contest 10 is an old one. Intersection of 3 circuit arrays, 2 sum BSTs, WP numbers, and valid palindrome 3. Intersection of 3 sorted arrays, strictly increasing, return array only integers that appear in all 3 arrays. Should just be able to do a linear scan, I suppose, of I, J, and K for A, B, and C. I equals 0, J equals 0, K equals 0. The output will be the same values that are in all 3. Well, actually, the fastest way to do this would be to just create them into sets and then do the intersection, right? Set A, B, C equals set A, set B, set C, and then return the intersection, A minus B minus C. Does that work? Intersection. How about this? It should be an array, right? So X, Y, and Z have a, for X in a if X in, right, X in B and X in C. I think that works, right? Nope. It's not ordered. Is that why? Only integers that appear in all 3 arrays. Well, these are integers that appear in all 3 arrays, but it's not ordered. Sorted. Okay, well, you should say return an ordered array, but whatever. Okay, so that's kind of like the cheaty way to do it. I just turn in the sets. Anyhow, let's do this one more time in C++, and we can do the linear scan. Here, let's do this 617 game plan via a linear scan. Okay, so I, J, K are the indices for these things. So while I is less than A dot size, and J is less than B dot size, and C, K is less than C dot size. If A sub I is less than B sub J, then we'll increment I. Let's see, if they're equal, then we'll use it, right? So if A sub I equals B sub J, and B sub J is equal to C sub K, then we'll put it in the answer, right? So the I answer to be returned as a pushback A sub I. In this case, we'll move them all forward. I plus j plus k, and then continue. Otherwise, if a sub I is less than b sub j, then we need to move a sub I forward. If b sub j a sub I is less than c sub k, b sub j is less than a sub. Oh, actually, how do we want to move these things forward? Maybe the smallest moves forward first. Let me get some music going on here. If A is less than B, actually, let's do this. So if A sub I is equal to the minimum of A sub I, B sub J, C sub K, B sub J, I'll move J forward. Otherwise, I'll move K forward. So basically, the minimum will move forward. I think that works. Let's see. 1, 5 to the samples. Okay. That looks okay. So it's a decent solution. Let's see, 621. More minutes. So maybe a better solution though is just to use sets, right? Using set equals set. Set answer. Try and answer that again. Answer that end. Put that into vector to be returned. Oops, hold on. Set A and B. Do that again. And then C. See that again. See the end. Set intersection of all three. Okay, so this will be A and B. A, B, B, C, set intersection, b dot begin, dot end, and c dot end, for BC. And let's just copy and paste this. So AB, BC to the answer. Inserter, set intersection. Set intersection. Let me look at the STL algorithm for set intersection. I thought that the last one was the output iterator. Okay. That's... I don't know if this will work. Maybe that begin. I don't think so. Right? No, it needs to be set intersection, not intersection. Inserter, maybe intersection. Inserter. What? Man, I don't know how to use this inserter. Output iterator, intersect, inserter. Inserter. Insert iterator. That doesn't look right. Oh, I guess it likes it. Okay. All right, whatever. Okay, set intersection, Oop. Okie dokie. Inserter BC. BC that began. This will be a answer can just be a VI, right? It's got to be a back inserter. Return answer. Okay. Yeah, that looks cool. So that's the set way of doing it. Okay, that's good enough for now. Okay, to some BSTs. Okay, so we're looking for a value in the left one. What's the value in the right one where the sum is equal? Okay. A and B, and this is our target. M equals our map. Just go traverse A and then try to find a corresponding value in B. I think that works, I think, right? Yeah. Which is a set, actually, right? Scene equals set. Def go. root. If not root, return. Scene dot add on local scene dot add root dot val. Go root dot left. Go root dot right. So traverse that tree, and then go A. I guess look at A. Go look at A to find what's seen, and then find roots. Need equals root dot val t minus root dot val, like the target subtracted by root val. So need plus root dot val equals t. All right, so if scene that has, if need and scene, then we return true. Let's find root dot left, find root dot right, and then return, oops. Otherwise return false. Oops, not false, so return that or this. So we propagate truthy value. Propagate the truthy value if it is ever seen. And then at the very end, we can do find, return find B. Go, oops, it's look, is what it's called, look. Okay, that looks good. Yeah, so nothing too fancy. The first pass of the first root, we just see all the values that are seen, and then we try to find what we need to accumulate the target T. So that's pretty legit. We can just do it in C++ here real quick. A, B, and our target. And go capture yourself neural lambda. Oops, actually, this is called look, right? Okay, so using fun equals function void. Got a fun one. And it'll be a tree node pointer as a parameter using fun2 or fun, yeah, a fun2 equals function cool tree node star fun1 look root, look at A to see what's seen. Ordered set of values, set of seen values, dot root, return, otherwise, seen that insert roots value, and then look at roots left, look at roots right, fun2, find, capture yourself in your own lambda, dot root, return, otherwise, need equals T minus roots of value. If scene.find need, scene end, return true, otherwise return find root.left, left, or find roots right. Return find B. Okay, that looks good. Oh, just as Boolean, return false, false. Okay, looks good. All right, that's good enough. I'm gonna see if I solved this one before. I'd be interested in see how I solved it. Oh, interesting. Binary search. What? Oh. What? Binary. Oh. And, pre-order traversal. What? Okay, this is pretty much what I did then. Pretty much implemented this. So what is this then? This binary search thing. Like, what the heck's going on? Target. Oh, you go through A and do binary search of B for each of those values. I see. I see. Okay, so do a binary search for each one as you go. It's quite a bit more complicated. I like this solution a little bit more, I think. Go take a look and then find what you're looking for. I don't know. There's trade-offs each solution, whatever. It's cool. Okay. Stepping numbers. A stepping number is an integer such that all the adjacent digits have an absolute difference, exactly 1. Okay. That makes sense. Given two integers, high and low, or sort of list of all stepping numbers in the inclusive range to 2 billion. Excuse me. Single digits are stepping numbers. Low and high. If okay, x. If x is less than 10, return true. Otherwise, take the last 2 digits of x. I guess last equals x modulus 10. X divided by equals 10. If last does not equal the absolute difference of last minus x modulus 10 does not equal to 1, then return false. Otherwise, return okay, so x. And low to high inclusive. Answer equals this, return the answer. If okay, x. Actually, let's do this, return x for x in range, low, high, +1, if okay, x. Right. Go, oops. Okay. Looks good. Ten, 12 are legit. See what happens. Taking a while. Oof, TLE. Oh yeah, you can't iterate from 0 to 2 billion. Ooh, maybe it needs to be built upon itself. What's previously seen, it can extend onto. I wonder. There's only so many candidates, right? And I'm considering all of them in a different way. Okay, so now we know it's going to TLE if we iterate sequentially. So maybe it makes more sense to do a depth first search and build it. Is the correct solution, but results in TLE because we cannot iterate from 0 to 2 billion. In linear time, right? We can't check all of them. We only, right? Instead, it makes more sense to perform DFS, right? Maybe, I think. So we can DFS from, we start at 10, 10 to 12. Let me consider this. Or actually, yeah, there's only so many possible abilities per length. Right, so when the length of the digit is 1, they have 0 to 9 inclusive. That's 2, they have 1, 2, 2, 3, 3, 4, 5, 6. Right. 1, 2, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9. 10? 10 as well. It's 3. It's 100 doesn't work. It's 1, 2, 3, 3, 4, 5, or 2, 3, 4, 3, 4, 5, 5, 6, or 4, 4, 5, 6, 5, 6, 7, 6, 7, 8, 7, 8, 8, 9. Is there a 0 on there? 2, 8, 2, 1, 0? Oh yeah, down. Yeah, 2, 1, 0. To go up and you can go down. So these are up and then down. 9, 8, 8, 7, 7, 6, 6, 5, 5, 4, 3, 3, 2, 2, 1, 2, 1, 0, 3, 1, 2, or 3, 2, 1, right? 2, 3, 5, 4, 3, 6, 5, 4, 7, 6, 5, 8, 7, 6, 9, 8, 7. Rah, 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 rah. Okay, yeah, so there's only a handful of possibilities, right? This is what I'm getting at. So it makes sense to only check these possibilities. Okay, so 10 exceeds 2 billion. Exceeds 2 billion. Hello? Oh, hey, good morning, partner.
Are you a conference call?
No, I was just practicing some Leetcode. Ooh, that's a good idea, Sen. Yeah, that sounds good. I love you, Sen. Okay, where were we? Okay, so these are the subsets of possibilities. So we can just try all these candidates, I guess. Okay, I mean, I think it works, right? Wonder if I should try to construct the candidates on my own or just hard code them in here. Just have an array of these things. Those are twos. These are okay, right? Be a set. Four, 5, 6, 7, 8, 9. Hold on, I need a trillion commas. The ones in between. Return x for x in. Okay. If low is less than or equal to x is less than or equal to high. Right, it's in between low and high inclusive. Oh. One argument? Oh. It needs to be like this. Okie dokie. 10. It's not getting 10. Oops, 10 is not here. Oh, I forgot my singles. Okay, hold on. 0, 1, 2, 3, 4, 5, 6, 7, 7, 8, 9. Okay, that looks legit. Uh-oh. I'm probably missing one somewhere here. Holy cow. Oh. Oh, there's a whole bunch I'm missing. Oh, it goes up and down. Oops, okay. Oops. Okay, so I solved the wrong problem. I thought, originally thought the question was asking about monotonically increasing, decreasing, but instead I see the values can go up So it makes sense to perform DFS then, right? DFS. My original, that was my original game plan. I was thinking more of DFS approach. So DFS from low. DFS from low till high. So every digital low can be modified and appended on. Okay, let's see how much time I have left here. About half the contest left still. Okay, so yeah, I'll come back and do DFS, right? So to do right, oops. Right, DFS solution. Yeah, for now I'm gonna go. I'm probably gonna, yeah, I'll quit now and play some Oregon Trail with my son. Yeah. Excuse me. Yeah, see you later.